let's look at how to round with significant figures. So you look at the next number to see if you keep the previous number the same or if you bump it up by 1. For example, 56.312, if we're going to round it to 4 significant figures, we're going to have 1, 2, 3, 4. And then the question is, what happens to that 1? Does it stay a 1 or does it bump up? And because it's followed by a 2, it's going to just stay a 1 and not bump up. So it's going to be 56.31. Okay, the next one, we're going to round this to 4 sig figs, and because the 1 is followed by a 6, that means we're going to go ahead and round it up, and so this would be 56.32. So here we have 715.89, and we're going to round it to 2 sig figs. So 7 and 1 are our 2 significant figures. First question is, what happens to the 1? Because it's followed by a 5, we're going to go ahead and bump it up to a 2. But be careful. You see this 5? It doesn't just disappear. It needs a placeholder because this is 715. It rounds up to be 720, not 72. However, everything after the decimal can be dropped off. So we're going to round this up to 720 and get rid of everything that follows the decimal. And so our answer is 720. Notice that we are rounding to 2 sig figs, but there are 3 places before the decimal. Fill in the empty place with a 0. Significant figures, if something is significant, it's big or important. The most significant thing is the biggest or most important thing. So if I have 3, 2, 6, 8, 3 is worth the most in this number, 3,000. It is the first significant figure. 2 is worth 200 and is the second significant figure. 6 is worth 6 tens and is the third significant figure. And 8 is worth 8 units and is the fourth least significant figure. So if I were to round this to be 1 significant figure, I'm going to round it at the thousands place. So this 3 is going to get rounded. The 2 means it's going to stay a 3. So look at the next digit. Since it's less than 5, we're going to keep it a 3. And then you need the placeholders, 0, 0, 0, for the hundred, tens, and unit place. Here we have 3, 2, 6, 8 rounded to 2 sig figs. So the 3 and the 2, because the 2 is followed by a 6, round it up to be 3. And then we need placeholders for the tens and the units place. Here. Be careful. 34.560 rounded to 3 significant figures is going to be 34.6, not 34.600, because this number has 3 significant figures. But if you kept all these zeros following the decimal, then we'd actually have 5 significant figures, which is too many because we only want to have 3, not 5. So be careful. Anything following the decimal will drop off. It is not a placeholder. Adding zeros to the end of a number after the decimal increases the number of significant figures. All right, so now how to round when you multiply and divide. Round to the same number of sig figs as the measurement with the least number of sig figs. So if I were to look at this example here, 8.63 has 3 significant figures, times 0.88 has 2 significant figures. The least of those is going to be 2 significant figures. So my final answer can only be as accurate as the least accurate measurement, and so it can only have 2 significant figures. So instead of 7.5944, that 9 means I'm going to round the 5 to be up, and so it's going to be 7.6. So now let's look at some practice problems. We're going to round to 3 significant figures. Notice that we have zeros leading in front. Those are not significant. They are placeholders, so I do have to keep them in my final answer. My 3 significant figures are these guys right here, the 1, the 6, and the 2. And then the 7 follows the 2, means I'm going to round the 2 up to a 3. I have to keep my leading zeros, and then it's going to be 0.00163. Round this number to 4 significant figures. Remember, everything in front of the times 10 is significant, so we just need 1, 2, 3, 4 numbers. Because the 8 is followed by a 5, I'm going to go ahead and round it up, and so that's going to be 3.609 times 10 to the 5. I have to keep the times 10 to the 5 because this number is in scientific notation. Round off the following numbers to 3 significant digits. So here I have 1, 2 significant digits, and I need a third one. I need that 0 to be significant. In order to do that, there's 2 options. One would be to change it into scientific notation, and then the other would be to put what's called a little dash over the 0 here. And so having that over a 0 that's not normally significant makes it significant. So now this has 1, 2, 3 significant figures. Or if I put it in scientific notation, then everything in front of the times 10 is at that point significant. Okay, next would be this 4.53619, and I need to have 3 significant figures, so it's going to be the 4, 5, and the 3. Because that's followed by a 6, I want to round the 3 up to 4, and so this is going to be 4.54. Okay, this one, 3 sig figs, 5.45, because at 5 is followed by a 7, that is going to be rounded up to be a 6. 5.46. Here, I need 3 significant figures, so 1, 2, 3. That 6 is followed by a 5, so I'm going to go ahead and round it up, and so this is going to be 43.7. All right, I got to keep my leading zeros. They're placeholders, but they're not significant. So my significant figures are these 3 that I want to keep. The 6 is followed by a 9, so the 6 is going to be rounded up. And so this is going to be 0.000877. Finally, this one, I have these 3 significant figures. Because the 6 is followed by a 4, I am going to keep it a 6, not round it down, just keep it a 6. Because this is 876,493, I need placeholding zeros for the 400, the 90, and the 3. So this is going to be 876,000. Okay, so we're going to write each answer with the correct number of significant figures. 11.6 times 6.24, if you put it in a calculator, you're going to get this. And then we got to look and see that this number here has 3 significant figures, and this number has 3 significant figures, and therefore I can only have 3 sig figs here. So we're going to have 72.3. The 3 is followed by an 8, so it's going to round up to be a 4, and that gives us 72.4. Down here, 0.004 times 5280. This number has 1 significant figure, and this number has 3 significant figures. So we're going to have to round based on the least, which is 1. So when we calculate this, we get 21.2. That's our raw answer. But we can only have 1 significant figure, so we're going to round it off right there. It's followed by a 1, so it's just going to stay a 2. I'm going to need a placeholder here for the 1. I'm going to have to put a 0 there, but everything after the decimal, I want to drop it off. And so our final answer is going to be 20. Here we have 5 significant figures, and here we have 3 significant figures. So the least of those is going to be 3. So when I calculate 500.55 times 5.11, we get this really long number right here. I can only have up to 3 significant figures, so it's going to be the 2, the 5, and the 5. This 5 is followed by a 7, so it's going to round up and become a 6. This 7 needs a place holding 0, and everything following the decimal needs to be dropped off. And so our final answer is going to be 2,560. This number has 1 significant figure, and this number has 2 significant figures. So when you multiply 1,000 times 8.2, you get 8,200. However, this is our least number of sig figs, so we can only have 1 sig fig in our answer. That's going to be the 8. The 2 is followed by a 2, so it's going to stay in 8. Don't round it up. And then I'm going to need a place holding 0 for the 2 and the 0 and the 0. There's no decimal, so nothing to drop off. So this final answer is just going to be 8,000. So let's do number 5. This is an actual density calculation that we're going to apply our sig figs rounding rules to. So it says calculate the density of the object. So I don't know the density. The volume is measured to be 3.2 milliliters, and the mass is equal to 29.000 grams. So let's take a moment to note how many significant figures each of these has. 3.2 is 2 sig figs, and this 29.000 is 1, 2, 3, 4, 5 sig figs. Trailing zeros with a decimal or ending zeros with a decimal are significant. So 2 sig figs is the least of my givens, and so my final answer can only have 2 sig figs. As a reminder, here's the little calculation triangle for density, which in these hard times we're going to go ahead and use. So if I want density, it's going to be mass divided by the volume. So 29.000 divided by 3.2 gives us 9.0625 is my raw answer, grams per milliliter. And we can only have two significant figures, so I'm going to round it off here. That 0 is going to round up because it's followed by a 6. And because all of these numbers follow the decimal, I'm going to drop them. So this final answer is going to be 9.1 grams per milliliter. Okay, and then we'll do number 6. It says find the volume. So the volume is what I don't know. I am told that I have a density equal to 0.893 grams per milliliter, and I have a mass equal to 25.322 grams. So let's take a minute and identify how many sig figs do each of these given values have. We have here a leading 0, not significant. The 8, the 9, the 3 gives this 3 sig figs. And then over here we have 1, 2, 3, 4, 5 significant figures. So our final answer can only have the least number of sig figs as our givens. So our final answer will be rounded to have 3 significant figures. Okay, so now we're going to calculate, and we'll use our little triangle. So because I'm looking for the volume, I'm going to take the mass and divide it by the density. And so the mass is 25.322 divided by the density is 0.893, and that gives me 28.356,10302. And so I can only have up to 3 significant figures, so that's going to round off here. That 3, based on the 5, is going to round up. And because all of these numbers follow the decimal, I'm going to drop all of those numbers off. And so my final answer will be 28.4 milliliters.